Good morning. I'm Andrew Turner from Cape Nature, where I work as a restoration ecologist focused on the main threats to biodiversity and ecosystems in the Western Cape province, and this includes invasive alien species. There are several new techniques and technologies for controlling invasive alien species, and what I'd like us to do today is look at how we can build up speed and momentum in implementing these methods. Invasive alien species are notorious for the ecosystem disservices they deliver. They negatively impact biodiversity and the ecological infrastructure and ecological services that are underpinned by biodiversity. They increase fire risk and can lead to situations in which fires are impossible to control. They decrease our water security by using up the valuable water in a water-scarce province, and this applies to much of the rest of the country too. They also affect food security because where these invasive alien species are growing, agricultural crops can't compete. And they've even been shown to affect human safety, with criminals using invasive alien species stands in which to conduct their activities. So we have all these negative effects that we need to manage, but we have limited techniques and much work to do to fix them. Time is not on our side. If we do not work quickly enough, the invasions will outpace management actions, and if we do not have the requisite funding and the continuity of this funding, we will also end up back at square one. So what I'll do here is review some of the new techniques and applications for plants and animals. It will not be comprehensive, but I hope to give you a flavor of the options out there. I'll break up the presentation into two parts, starting with plants, and then we'll move to animals. So we'll start with techniques used for gathering data about invasive alien species. Knowing where invasive alien species are is an ongoing challenge and is often best solved with remote sense data. And this is where satellites, unmanned aerial vehicles, better known as drones, and artificial intelligence can help. Satellite imagery data is not new, but it is getting better all the time, with sub-meter imagery available at just 60 US cents per acre, and 10-meter resolution data is available for free. Drones are excellent for the small spatial scale projects, providing very high resolution imagery. You can even identify small plants with these, and this is great information to have when you're planning how much work you have on your hands and if you're making progress in dealing with the species. However, there are a few catches. The better the resolution and the more frequent the updates, the higher the analysis burden, but artificial intelligence detection routines are likely to solve these classification difficulties. In the slide here, you can see an image where drone footage has been used to identify the locations of each individual pine tree in a mountain near Franschhoek. Now we move on to clearing techniques, and one of the techniques run by the Mountain Club of South Africa is known as the HeliHack team, which uses helicopters flown by expert pilots to dangle people on ropes to get them to inaccessible sites in the rugged mountains of the Western Cape to cut down pine trees with chainsaws. This is not a technique for the faint-hearted, but it is highly directed, and this technique is covering a gap till other technologies become available, such as ABBA. And ABBA is not a prissy 70s pop group. It actually stands for Aerial Basal Bark Application of Herbicide, using a long lance as an applicator from a chopper, a technique that has been perfected in New Zealand. It produces a highly directed stream, as the herbicide is diluted in a carrier oil, and is in fact much more directed than this picture indicates, as this was just a test with water. And with a helicopter, you can get to very remote and difficult trees. It is also very efficient, as the helicopter spends only a few seconds per tree and can get to the next tree very quickly. It is, however, only suited to lowish densities, as there has to be space to maneuver the chopper safely and apply the herbicide accurately. Then, similarly to ABBA, you can use the same technique on the ground. Most current knapsack operators use foliar sprays, but with ground-based basal bark application, you can direct the herbicide directly onto the stem, and this limits the off-target effects. It's also an easy and fast way to apply the herbicide, and it can be done at multiple densities. It's not just limited to the low densities. It's also quite maneuverable, and you can get in between stems and rocks and other obstacles. And then one can also literally shoot invasive alien plants with a paintball gun, in which the paintball is not filled with paint, but a mixture of herbicide, or potentially a biocontrol agent. This method has not been deployed in South Africa yet, to the best of my knowledge, but it may fall under aerial application for registered herbicides for certain species, so it may be worth investigating whether this can be applied to certain species in South Africa. Another promising technique developed in New Zealand is drill and fill, in which holes are drilled into the cambium of a tree at an angle, and herbicide is squirted into these holes. This is another highly directed method that should only affect the target tree. It can also be applied in dense infestations where chainsaws may be impractical or dangerous to operate. Biocontrol itself is not a new method, but new biological control agents are continually being developed for new invasive alien species and to improve management of existing alien species. In the Western Cape, the stink bean Paracerianthes is becoming increasingly common and pops up in vast numbers after fire, but now has a rust fungus agent available. New agents also need to be tested for species lacking biocontrol. Pines sorely need biological control in the Western Cape province, and a new research project is being initiated for improved pine management with the Centre for Biological Control, the Forestry and Agriculture Biotechnology Institute, and Forestry South Africa. And there are new techniques for animals too. Whenever control of animals is contemplated, animal welfare is a valid concern, but one also has to consider the welfare of our indigenous animals, and that they may be affected by invasive alien animals. For example, house mice and Indian house crows eating our indigenous animals. There are many kinds of traps available, but one of the ones that may really improve efficiency is having self-resetting gas-operated traps. So these traps can kill several animals without the need to be cleared, and they do it humanely and have no secondary effects on the scavengers or predators because there's no use of any poison involved. But there are occasions where poisons are necessary. Aerial baiting, in which herbicides in pellet form are dropped from the air, have been successfully applied on numerous islands to eradicate rodents. A proposal is being developed to control both European rabbits and house mice on Dawson Island off the Western Cape, but it is possible that Dawson Island is small enough to conduct these operations from the ground. And then moving into the aquatic regime, invasive alien fish have very rapid and dramatic effects on our indigenous species, so it is essential we have a technique to be able to deal with invasive alien species lurking in our rivers. Rotenone, or CFT legumine as the active ingredient, has been shown to be very effective, and not only is it effective in controlling invasive alien species, it allows full recovery of the full suite of indigenous species once the treatment is over. As far as I know, however, it is not registered for general use in South Africa yet, despite it being a very useful tool for us. Biocontrol can also be applied to animals. Although this has been largely restricted to insects, it can also work on vertebrates, such as the use of various lethal viruses to control rabbit populations in Australia and elsewhere. One insect where we really do need a biocontrol option is the polyphagous shothole borer beetle. It is so difficult to detect and treat, especially in the wild, because it is so capable of establishing colonies from a single founding female, and then they are protected within their tunnels inside trees. So biocontrol is one of the few options that may be feasible for control of this tiny insect. The other option may be some other form of gene drive. Then a really new and rapidly evolving method is a gene drive. There are several ways in which gene drives work, but the basic principle is that genetic manipulation is used to increase deleterious gene frequencies, such as those that cause lower reproduction or altered sex ratios, to frequencies beyond those obtained by normal Mendelian ratios. So if you compare the diagram on the left, you'll see in a normal population the ratios stay the same over time, but with a gene drive, a particular gene actually increases in frequency, and this can be done by copying and pasting that gene into the next generation using the Cas9 nuclease. This then reduces the population viability and eventually the numbers, leading to some degree of control. Laboratory-based studies have proven that the concept can work in animals, but it won't work in all circumstances. It is more likely to succeed with closed but actively mixing populations. In open populations, the gene drive could escape into native populations where it may cause some harm. In smaller populations, the gene drive has a better chance of completing its spread and will require fewer initial carriers. This technique is not ready for deployment yet, although reversible systems have been designed. It is even more challenging with plants because plants have typically seed banks which can supply a constant source of non-altered genomes, and they also have the ability to self-fertilize. So, we have a bunch of new methods out there, and there are several that I have not mentioned, like drone-based deployment of biocontrol and insertion of Wolbachia genomes. But, unfortunately, on the road to implementing new techniques, there are many obstacles to trip us up and slow us down. One of the things holding us back are perceptions that may not be well grounded in evidence. Scientists may be hesitant to push for solutions that are not supported by various other parties across the public spectrum. We should support research that obtains the evidence that we need to make wise decisions. But perhaps an even bigger problem is the red tape that needs to be negotiated to register new methods. If any proposed solution falls within the ambit of the Agricultural Remedies Act 36, then there is a tough road ahead, with a difficult application and registration process that does not overlap well with what conservation scientists typically do. And on top of that, there is apparently a massive backlog and a long delay in dealing with applications to the registrar. Last, but certainly not least, is funding. Sufficient funding to eradicate, or at least successfully control, invasive alien species is seldom available. Furthermore, this funding needs to be consistently and regularly available over time. Any hiatus in funding can lead to the species returning to pre-control levels and can ruin chances of a control program's success. So there are a host of advances that we should be picking up on, but we need to do a few things to gather speed and momentum. We first need to step back and integrate the various options we have to tackle a problem comprehensively, decisively, and speedily. Perhaps we need a forum for us to collaborate and drive for solutions and overcome these obstacles. We need ownership of the problems and their solutions. We need motivation and drive for continuous funding to push towards success. If we do this together, I think we will gain sufficient momentum to improve the situation. But whatever we do or don't do, we need to monitor and quantify these effects on biodiversity and ecological infrastructure. This way, we will gain the evidence we need to make the decisions that we need in adaptive management. Our response will have to be flexible, sensitive to the environmental context, and fast enough to achieve our goals. And with that, I thank you all.